In this video, we will discuss about combination sum. So first, let's understand the question. Given an array of distinct integers candidates and a target integer target, return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combinations in any order. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. So what they are saying is that in the input, we are given an array of integers where all the elements are distinct and we are given an integer target. Now what do we need to do is, we need to find out a list of all unique combinations of the elements of this array where the sum of the numbers in each combination is equals to the target, right? Another thing that they have mentioned is that you can take a number any number of times, right? So that means if you have considered 2, then that doesn't mean you cannot take 2 again, right? So if you see, one of the possible answers is 2, 2, 3. Here the sum of these three numbers will be equals to the target, right? So here we have picked 2 twice and 3 once, right? So now whenever you are having any question which involves an array of integers and it asks us to find out some combination of the elements of the array, right? Now here there are more chances that this problem will get solved using recursion, right? Why using recursion? Because if you will closely look, that for every element in the array we will have two choices, right? We'll have two choices. One choice is that you take it and the other choice is that you do not take it, right? Either 2 will be considered in our answer or it won't be considered. Now in this question we are given that we can use a number an unlimited number of times, right? That means 2 can be used any number of times. In this answer we have used it 2 times, right? So for this 2 or for any element in this array, we will have two choices. Either to pick it some number of times, right? Or we do not pick it, right? So we will have two choices, right? So now let's see how are we going to approach this. So let's quickly give the indexes. So initially we will start with the first element, right? So initially your I will be 0, right? What all other things are we going to maintain? So what do we need? What is our end goal? So for every array element, we will consider two choices that we will either take it or we won't take it, right? So at every point you will get some array, right? At every point you will get some array. Now what this array should satisfy, that its elements sum should be equals to the target, right? So at each step I need two more things. One is the current sum which will initially be 0 and other will be my current array which will be initially empty. So one I will store the current index, the current sum. This sum will be nothing but the sum of the elements in this array, right? So initially sum is empty because the array is empty and I is 0. So now when we are at the first element, so we have two choices here. Either we will pick it or we will not pick it, right? So when you will pick it, what will be your sum? Your sum will become 2, right? Because we have considered the element 2 and your array will also contain 2, right? Now what will be your index at this point? See, we can consider 2 any number of times, right? So if I will increase my index here, then I won't be able to consider 2 again, right? So I'll keep the index as is. I won't change it. I will keep it as 0 so that I can consider 2 again. If in the question, if it would have mentioned that we can take 2 only once, then at that point we would increase it to 1, right? But here we are keeping it as 0, right? So now what will happen is, when we are not picking it, in that case we will increase our index, the sum will remain as is and the array will also remain as is, right? Now here this is our sum, this is our array and this is the index. Now again for this index 0 we have two choices, right? Either we will pick it or we will not pick it. So now when you will pick index 0, that is element 2 again, then at that point your sum will become 4 and the array will become 2 comma 2. Now we can take 2 more number of times, so again we'll keep the index as 0 only, right? So now again what will happen here is that again you will have two choices, either take it or do not take it, right? So now your sum will become 6 and the array will become 2, 2 and 2, right? And we'll keep I as 0 only. So now again for this you will have two choices, either take it or do not take it. So now if you see that our index is 0 and the element is 2. Now if you add one more 2 here, what will be your sum? Your sum will become 8, right? What was your target sum? It was 7. 8 is greater than 7. So if you consider 2 at this point and then you keep on considering 2 again and again, what will happen? It will only increase your sum, right? We will never be able to get a sum that is equals to 7, right? So whenever my sum is getting greater than my target sum, I will simply stop there, right? I won't go further. So this gives me a base condition that if my current sum becomes greater than the target, then I should stop here, right? So now coming towards this path, so here we have not taken index 0, so our index will become 1, our sum will remain as is and the array will also remain as is, right? Now for this also you will have two cases, either take it or do not take it. So now what will happen when you will take index 1? So the value at index 1 is 3. So now if you will add 3 in the sum, then it will become 9, which is greater than the target. So that means we will stop here, right? Then in this case our I will become 2, sum will remain as is and the array will also remain as is, right? Now for this also we have two cases, take or don't take. So now when you will take index 2, what is the element at index 2? It is 6, right? So now when you will add 6 in 6, your sum will become 12, which will be greater than the target. Then that means you will stop here, right? And when you won't consider it, then your I will become 3, your sum will remain as is, array will also remain as is, right? Now for this also you will have two cases, take it or don't take it. Now if you will see that the element at index 3 is 7, if you will add 7 in 6, again it will become greater than the target, so we will stop here. And if we don't take it, then our I will become 4, our sum will remain as is and the array will be 2, 2 and 2. So now you will consider the element at index 4, but if you see that we do not have an index 4, right? So then that means at this point I cannot go further and I should stop here, right? So we got another condition, another base condition, that if at any point your current index becomes greater than or equals to the size of the array, then you should stop, right? Now in our code, before these two base conditions, we will check that if our current sum is equals to the target, right? Then we will store it somewhere. We will store it and then we'll return from here itself. So if in any case you are at index 4 and your sum is equals to the target, then this condition will be true. You will be able to store it and you will return from here itself, right? So in that case it won't come here, right? So that's why we are only checking that if the index is greater than equals to size, then stop, because current sum equals to target sum we have already checked before this condition, right? So now if you will see, this path is finished, right? All of these paths that we were considering are finished now. So what recursion will do? It will backtrack, right? Now it will go back. So this will go back here, this will go back here, this will go back here. Now when this will go back here, the other call that will happen is this one, right? This one will happen, right? So now what will happen is, if you see here, that at this point our array was 2 and 2, right? We had two choices, either take index 0 or don't take it, right? So when we considered the path where we took index 0, at that point we added one more 2 in our array, right? But when we come back to this path, then at this point this 2 should not be present, right? Because we are not picking it, but same array we will be using in all the recursion calls, right? So before you come at this point, you should remove this 2, right? So that means what you will do is that whenever your recursion call finishes, whenever one of the recursion call finishes, you will remove the last element from your array, right? So for this path, only 2 comma 2 will be present in your array, okay? So now let's remove this left side because we don't need it. So now if you will see here, when we have not taken index 0, then at that time what will happen is that I will become 1, your sum will remain as is and your array will also remain as is, right? Now for this we will have two scenarios, take it or don't take it. Now when you will take it, what is the number at index 1? It is 3, right? So now if you will see that your I will become 2, your sum will become what? 4 plus 3, 7, right? And your array will become 2, 2, 3, right? Now at this point you will see that your current sum has become equals to the target, right? And as I said, if your current sum becomes equal to target, then you will store it somewhere and you will return. So you will store this array because this is one of your answers, and you will stop here. You will stop this recursion call, right? So it will come here, and then this 3 will be popped out, and in this case I will become 2, sum will remain as is, array will remain as is, right? And then the further call will happen here. Then it will go back, then this call will happen. Then when it is completely finished, then it will come here, then this call will happen. So at the end, whenever you have traversed all the paths, you will be able to find out all the different combinations where the sum of the array elements is equals to the target. Okay, so this is what we wanted to achieve. So now let's code it out. So first of all, we need to create an answer vector, right? This will store our answer, so it will be vector of vector. Next, we need to create a vector which will store our current array, right? And then we need to call our recursion function. So let's name it make combinations, right? So now let's see what is it going to receive in its parameter. First, let's create this function here. So it will be void, it won't return anything. Now what all it will receive in the parameters? So first it will receive this candidates array, right? So we'll do candidates, then it is going to receive the target, right? Then what else do we need is, we need the current sum, we need the current index, we need the answer vector, right? We need the answer vector, and we also need the current vector, right? So now let's pass these elements from here. So first we need to pass the candidates vector, then the target, next the sum which will initially be 0, then the index, this will also be initially 0, then our answer vector, and then our current vector, right? Now at the end, this answer vector will be storing your answer, so we will simply return answer, right? Now what are you going to do in this recursion function? So as I said, for the current index, you are having two choices, take it or don't take it. Now when you are taking it, in that case what you will do, you will update the sum and you will add this element in the current array, right? So first of all, let's add it in our current array. So it will be current dot pushback candidates of index, right? And then we'll call this recursive function again, right? Now what all it will receive? It will receive the candidates array, right? Then it will receive the target. Next it will receive the sum. Now what will be your sum? Since we have taken into consideration this element, so now your sum will become sum plus candidates of index, right? What will be your index? So we will keep index as is because we want to consider this element more number of times, right? So index will remain as is, answer will remain as is, and cur we have already updated, so we'll pass it as is, right? So now after we are done with this recursive call, now we need to think about the path where we are not picking this element, right? So before making that recursive call, this number that we have pushed in our current array, that we need to remove, right? So we'll do cur dot pop back. So what it will do is, it will remove the last element of your current vector, right? And then you can simply make call to your recursive function. So now this will receive the candidates vector, the target. Now what will be your sum? Since we are not considering the current element, so our sum will remain as is, our index will increase by 1, and our answer and current vector will remain as is, right? So now we are done with this. Now let's think about the base cases. So as I told you, for the base cases, first of all we'll check that if our sum has become equals to the target, right? That means the current vector that I am having right now is one of the possible combinations where the element sum is equals to the target. So I will store it in my answer. So answer dot pushback current, right? And we'll return. Why we are returning? Because sum has already become equals to the target. If we'll go further, then our sum will only increase. It will never be equals to target again. So that's why we will return. Then if at any point our sum becomes greater than the target, or the current index becomes greater than the candidate's length or the candidate's size, then in that case also we have to return. So this will be our recursive function. So now let's run this. So the test cases are accepted. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.